Hi friends, hi everyone, welcome to our channel BSc Engineer. In this video we are going to discuss about engineering geology and mainly about megascopic and microscopic properties of igneous rocks. So in the part 1 we have discussed about mainly granite and also about pegmatite in detail about these megascopic and microscopic properties. So in this video we are going to discuss about dolerite, basalt and other igneous rocks. Dolerite. The term dolerite was coined by Howe, which refers to a dark. So, the term dolerite explains or it refers a dark, heavy, fine-grained igneous rock. So, the properties were explained here in simple statement. It is a dark rock, heavy rock, fine-grained igneous rock. So, this is the most common found hyperbasalt rock. Among the hyperbasalt rocks, hyperbasalt variety of igneous rocks, this is the most commonly found one, and it is a intermediate in composition and characteristically melanocritic. Melanocritic means nothing but dark colored. Dark colored rocks are called melanocritic. So here it is intermediate in composition, means based on the silica content, if we see, it will be intermediate, saturated, undersaturated and intermediate. So it is intermediate in composition and characteristically if we see, it is a melanocritic. So mineralogical and chemically it is similar to gabbaro and basalt. So if you see the composition of this dolerite will be similar to igneous rocks like gabbaro and basalt, gabbaro and this dolerite. All these three are having a similar chemical composition or the mineralogical composition will be same. So composition of these dolerites, if you see, composition consists of mainly phallico-clase feldspar and pyroxenes. Phallico-clase feldspar and pyroxenes, iron oxides, hypersthene, biotite occur as the common accessory minerals. Iron oxides, hypersthene and biotite are the common accessory minerals, but mainly this dolerite consists of phallico-clase feldspar and pyroxene, augite feldspar as well as phallico-clase feldspar. These two are combinedly they form up the dolerite. So these two are the essential minerals. Phallico-clase feldspar and pyroxene are the essential minerals. Without these two minerals, we cannot say that it is dolerite. So olivine is sometimes found in the parent magma and was deflect of silica. Olivine is also found sometimes along with this dolerite. So that is also found in the magma. So coming to the texture, if you see the texture, dolerite is a massive and compact rock. So that is the reason it is having more advantages. So it is a very massive rock, more weight will be there, and also it is a compact rock. Compact rock means more densely packed arrangement is there. So grains are densely packed. So that is why it is more compact and more strength there. So it is neither porous nor permeable. So the first statement only clearly helps us to understand. So it is massive and compact. So when it is compact, so definitely the pores which was present in the grain to grains will be very less. So when it is a compact rock, definitely it will be having less amount of pores. That is why when less amount of pores are there, permeability also will be very less. So that is why these dolerites are massive and compact and they are neither porous nor permeable. The texture in the dolerite is generally equigranular texture. Interlocking texture is also more common in the dolerite. So equigranular texture means the grain size, the particle size will be same throughout. Same sized particles will be present in the dolerite. The grain size is same. That is why equigranular texture we call. So interlocking texture is also more common in the dolerite. So under microscope, dolerite exhibit aphanitic and subaphanitic texture. So when we are studying under microscope also they exhibit aphanitic and subaphanitic texture, means light emitting capabilities. So now coming to mode of occurrence. Mode of occurrence, if you see, occur in the nature as a intrusive rock, as a dikes and in granites. Most commonly, these rocks are available as dikes in the in granites. So these dark colored rocks are predominantly noticed in the field by virtue of the color contrast with the surrounding granites, which are light in color. So these dolerites are easily identified. Why? Because they are dark in color, dark contrasting color will be there, and they are available with granites. So that is the reason the surrounding granite will be in light color, whereas this dolerite will be in dark color. So that is why it can be easily identified in the field by virtue of their color dominance. So this is the picture you can see here. Dolerite, dark colored appearance and a fine grain texture and equigranular texture we can observe here. All grains are of equigranular size. So types, coming to the types of dolerite, there are so many varieties of dolerite based on the chemical composition, based on the availability of minerals in that dolerite. So a massive rock with a melanocritic, equigranular, compact, phenolitic, medium to fine grain texture is a typical dolerite. Means generally if we take a normal dolerite, it consists of mainly it will be having these following properties. It is a melanocritic, means dark colored, equigranular texture will be there, compact, phenolitic, medium to fine grain texture will be there, and that is the common identification for normal dolerite. So here, coming to the classification, slightly unsaturated and olivine bearing type is called olivine dolerite. So if this is available with more presence of olivine is more predominant and slightly unsaturated variety, then it is called olivine dolerite. Olivine dolerite. So next one, slightly oversaturated and quartz bearing type is called quartz dolerite. So if the silica content is more, slightly oversaturated and quartz bearing, quartz is the more predominant, then it is called quartz dolerite. Similarly, dolerite with a porphyritic texture, if the texture of the dolerite which was available there is porphyritic texture, then it is referred as dolerite porphyry. Dolerite porphyry. So dolerite with the completely weathered minerals is called diabase. So if the dolerite is made up of completely weathered minerals means the minerals which are part of the weathering or which were formed out of weathering naturally, the weathering process which was done naturally, because of that these minerals were formed. Then if those minerals were more predominant in this dolerite, then it is called diabase. It is called diabase. Next, a plutonic equivalent of dolerite, coarse grain type, is called basalt. Coarse grain means they are available at a greater depth. Okay, so that is why coarse grain type is called basalt. So coarse grain texture is available in the rock because of this depth. Why? Because cooling, more rapid cooling is going to take place. So that is why slow cooling is going to take place. That is why it is called a plutonic equivalent. So the plutonic equivalent of dolerite is nothing but basalt. It is called basalt. So glassy equivalent, another variety, that is glassy equivalent. Glassy equivalent is called trachylight, trachylight. Glassy equivalent of dolerite is called trachylight. So these are the various varieties we are having with this dolerite. So next, now coming to basalt. So basalt is a mafic, extrusive, fine grained, dark green to blackish rock with a porphyritic texture. So it is a mafic mineral. It is a dark colored mineral, dark colored rock, igneous rock, extrusive igneous rock. Intrusive means which is available below the ground surface. So here it is a extrusive igneous rock. Basalt means which is available on the ground surface, which is formed after solidification of lava which was expelled out of this volcanic eruptions. So that is the reason it is called a extrusive igneous rock. So it is a extrusive fine grained rock. It is a extrusive fine grained dark green to black volcanic rock with a porphyritic texture. The texture of these rocks is porphyritic texture. Basalt is composed of primarily of pyroxenes, and also another important thing is calcium, pyroxene and calcium rich phalligoclase with small amounts of olivine and amphibole. So the composition of basalt, if we see, it is primarily made out of pyroxenes and calcium rich phalligoclase. Phalligoclase means nothing but feldspar. So pyroxene and feldspar is the major components which are going to make out this basalt along with the olivine and amphibole. So essential minerals are pyroxene and calcium rich phalligoclase or feldspar. So these two are the essential minerals which are forming or which are making out this basalt. So minerals, coming to the minerals, if we see, there are so many minerals available with this basalt. So it is a simple mixture of labradorite, augite, iron oxide. It is similar to dolerite in mineral content. Biodite and hornblends are also occurring as rare minerals. So here if you see the composition, labradorite and augite. So these are the two. Augite is the essential mineral, and iron oxide is also present in this basalt, and similar to dolerite in mineral content. So the mineralogical composition will be same as it how the dolerite is having. Biodite and hornblends are also occur as rare auxiliary minerals. So pyrites may also be seen sometimes. Pyrites are also available along with these basalts, and quartz or olivine may appear in small amounts depending upon the silica content in the parent lava. So we have already discussed now. So the parent lava, the lava from which these basalts are formed. So if it is containing silica content, then only we can see either quartz or olivine may occur in small amounts along with these basalts because of this parent lava. So here you can see images related to this basalt. Fine grain texture, you can see fine grain texture with vesicles. Vesicular texture is available with this basalt. So that is only we are discussing now. What is the structure and texture? So the structure and texture of the basalt, if you see, it is a vesicular texture and amygdaloidal structure. Means sometimes the vesicles may not be filled with any other foreign material, then it is called a vesicular texture, and sometimes the vesicles may get filled up with some another foreign material, different material, then it is called a amygdaloidal structure. So these two varieties are more common in this basalts. So columnar texture and flow structures are also observed in some cases. Why? Because columnar textures or flow textures mainly these are made out of volcanic eruptions, right? Densification of volcanic eruptions. So that is the reason columnar structure or flow structure is more common with this basalts. Basalts exhibit aphanetic texture in hand specimens. That is, minerals are too fine grained, very fine content particles are present with this basalts. That is why it is called aphanetic texture. Then coming to availability and mode of occurrence. So basalts are the more abundant volcanic rocks. Their quantity is 5 times greater than all over the volcanic rocks put together. So they are more plentifully available. These basalts are more abundant among the volcanic rocks, among the igneous rocks. They occur as a flat or slightly inclined lava flows. So why? Because these are formed out of densification of lava. That is why they are available as a flat and slightly inclined lava flow surfaces. So this is about availability. Next, coming to appearance in hand specimen. So if you see basalt, it is a typically black or greenish gray or greenish black color. So the color of the basalt, if you see in a hand specimen, it will be greenish or gray or black in color. Sometimes it may be non-vesicular and sometimes it may be fully vesicular also. Massive in nature, weight will be there and exhibit a typical aphanitic texture that is extremely fine grained. So the granules or the particles will be very fine without or with vesicles. Basalts are always unstratified, unfossiliferous and do not react with any acids. So if we see any acid test, if we conduct any acid test, it should not show any reaction, and also it does not contain any fossils, and also it is unstratified. Layer wise stratification should not be there. If it is present, it is not basalt. So that is why basalt is free from stratification, unfossiliferous and does not react with any acids. So vesicular basalt, it is characterized by the presence of empty cavities or vesicles. So two varieties of basalt are there, vesicular basalt and amygdaloidal basalt. So vesicular basalt means if the surface or if the appearance, if it is having full of vesicles, then it is called vesicular basalt. And if that vesicles are filled with any material, the cavities are filled by secondary materials like silica, amethyst, opal, agate, geolite, calcite, etc. So if they were filled up with all these materials, then it is called amygdaloidal basalt. Silica minerals may be used as a semi-precious gemstones. So the silica minerals which are present in the vesicles of this basalt, those are considered to be semi-precious gemstones, or they are considered to be gemstones. So that is why this that is the importance of these amygdaloidal basalts and vesicular basalts. Next one, varieties. Coming to the varieties of basalt. Spillite is the soda-rich basalt in which phallicoclase feldspar is albite, or oligoclase is instead of labradorite. So instead of labradorite, if the phallicoclase feldspar is present, then it is called spillite or soda-rich basalt. Next, dolerite is the hyperbasal equivalent of basalt. Gabbaro is the plutonic equivalent of basalt. Plutonic variety. Among the plutonic varieties, it is a gabbaro is equivalent to basalt, and tarsylite is equivalent to glassy basalt. Alkali basalt is unsaturated basalt. Tholite is the oversaturated basalt. So all these are different varieties of basalt, or similarly dolerite. We have discussed dolerite varieties. So they are similar with basalt. So that is why both are same almost. So coming to the properties. So what are the properties of this basalt specimen means? Firstly, it is a massive rock and it is highly durable. It is having high durability. It lasts for longer time and strongest also. Next, not only strongest, what is the reason for strongest means they are having compact nature, hard and tough, but also more fine grained than dolerite. Granularity is also very fine. So for these reasons, basalts are extensively used as building stones. That is the reason basalts which are not a cavity, non-cavity free, means if it is not full of vesicles and if it is free from vesicles, then those varieties of basalts can be used as a building stone also. So as a road metal, the basalts are excellent for macadam and bitumen roads. So in the case of macadam roads and bitumen roads also, as a road metal we can use this basalt. Why? Because they are highly durable and strongest, and they are highly compact also. So that is the reason they can be used for road metal also. They are hard and tough and wear resistant to use as a building material, and also they are having good binding properties. That is the reason it is used as a building material very effectively. So this is about properties. Next, coming to gabbaro. So gabbaro refers to a large group of dark, coarse-grained, intrusive, mafic igneous rock which is chemically equivalent to basalt. So all these are similar varieties, but little or small differences will be there when compared to dolerite, or when compared to basalt, or when compared to gabbaro. So there are large group of dark coarse grained intrusive mafic igneous rock. So another important simulation we have to see here. So that is all these are igneous rocks. So whether if the igneous body or whether the magma which was present below the ground surface, if it is expelled out, then it is called basalt, or it is called extrusive igneous rock, right? Among that, basalts are more common. So it is called basalt. So if it is densified below the ground surface, then it is called gabbaro simply. Why? Because it is a intrusive rock, intrusive mafic rock. So intrusive nature means if it is solidified below the ground surface, right? So that is why nothing but the basalt, before, if the magma densified below the ground surface only, then it forms as gabbaro. If the magma expelled outside, then it forms as a basalt. So the rocks are plutonic, formed with molten magma and is trapped beneath the earth's surface and cools in the crystalline mass. Crystallization is going to take place here. So gabbaro is dense, green colored and contain pyroxene, phalagoclase, amphiboles and olivines, as it is the same what were present with the basalt also. Pyroxene is mostly clinopyroxene. Small amounts of orthopyroxene is also present. If the amount of orthopyroxene is greater than amount of clinopyroxene, the rock is called norite. So the name is going to be changed, gabbaro name, as norite if it is containing orthopyroxene instead of clinopyroxene. So here you can see it is a figure or image of gabbaro. So quartz gabbaros are also known to occur and probably derived from magma that was oversaturated with silica. So if the magma is having silica saturation, if more amount of silica is present, quartz gabbaros are going to be formed. Essentites represent gabbaros whose parent magma was undersaturated with silica, resulting in the formation of feldspathoid mineral nepheline. So here what is happening, if the silica content is less in the magma before densification, then that results in formation of excess essexites. So essexites are the another variety of gabbaros which are having less amount of silica, unsaturated silica content, leading in the formation of feldspathoid mineral nepheline. Nepheline is present in this rock. Next, gabbaro contain minor amounts of iron titanium oxide such as magnetite and ilmenite. So these two are present in very less quantity. Generally, properties, if you see, it is a coarse grained crystal in it is a coarse grained with crystals in size range of 1 mm or greater. Finer grained equivalents of gabbaro is called diabase. Next, gabbaro is usually equigranular in texture and it may be porphyritic at times, means coarse grained sometimes, especially when phalagoclase oikocrysts which have grown easier than grounder mass minerals. So sometimes if the crystallization is rapid, then it leads in the formation of inequigranular texture or porphyritic texture with this gabbaro. Coming to the uses, these are more commonly used as a valuable amount of chromium, nickel, cobalt, silver, gold, platinum, means it contains some valuable minerals. So gabbaro is a storehouse of these valuable minerals. Generally we say pegmatite is the storehouse. Gabbaro also we can say, why? Because it is also going to contain some amount of chromium, nickel, cobalt, gold. So rare minerals or some commercially valuable minerals are present here. So gabbaro is widely used as a crushed stone for coarse aggregate, road based material and railroad ballast. So mainly in the road works for concrete, similarly for road bases and railway ballast, we are using this gabbaro. Why? Because they are more compact and more strength. Smaller quantities are cut and polished for dimension stone and called black granite. So if they are available in smaller quantities, they are cut and polished for dimension stone and called black granite. So for markings and dimension stones means for plotting everything we'll be laying the stones, right? So for those uses we'll be using this gabbaro stones for layout stones, dimension stones. So this is about megascopic and microscopic properties of igneous rocks. So with this megascopic and microscopic properties of igneous rocks is completed in two parts, part 1 and part 2. Hope you understand well. Thank you.